Okay, today's topic is trigonometric ratios of any angle. Okay. And we start this by drawing an angle in standard position and saying that on this ray that forms the terminal side of the angle, here's the angle theta, is the point xy. Okay, so what we're going to do is find the trigonometric ratio, the trig ratios, all 6 trig ratios of this angle based on that information. Okay, and I'm going to write down a couple definitions, and these are in the book, and you can, well, you can't see them in the book because you don't have books, but these are the definitions. First of all, we construct a little right triangle here, and this is side x, that's side y, and we're going to call that side r. R is equal to, because of the Pythagorean theorem, r squared is equal to x squared plus y squared. So r is equal to the square root of x squared plus y squared. Okay, now definitions is that the cosine of theta is equal to x over r. And it basically follows the SOHCAHTOA that we've talked about before, adjacent over hypotenuse. Sine is y over r, which is opposite over hypotenuse. Tan is y over x. And the reciprocal functions, we have secant theta is r over x, cosecant theta, r over y, cotangent theta, x over y, adjacent over opposite. Now the thing that's different about this is that this point xy could be anywhere. Now r, being the distance from the origin to the point, is always going to be a positive. This is a positive root, so r is always positive. X and y can be negative. So when the point xy is over here, cosine is going to be negative, sine is going to be positive, and there's a way to remember this. Of course, SOHCAHTOA still applies, adjacent hypotenuse. But there's another tool that we use to remember this. Okay, now I say that all students take calculus, and these are the quadrants 1, 2, 3, and 4. In the first quadrant, all of the trig functions, and we're talking about 3, the 3 that are found on the calculator, sine, cosine, and tangent, are positive. In quadrant 2, sine is positive, the other 2 are negative. In quadrant 3, tangent is positive, and the other 2 are negative. In quadrant 4, cosine is positive, and the other 2 are negative. Now we can use that information to answer the questions that we're about to start with. Okay, now keeping all this in mind, let's take a look at problem number 1 out of section 5.3. It says, given a point 4, negative 3, find the sine, cosine, tangent, secant, cosecant, cotangent of all 6 of those ratios for theta. Okay, first thing we do is draw the angle in standard position. Negative 4, 3 is something like that, let's say. Okay, I draw the terminal side. Here's the initial side. Here is angle theta. Okay, drawing this little, actually I should make that go through the point. All right, here's our right triangle. This side is 4, that side is 3. Now, even though that says negative 4, this is a triangle, and we're going to label these as positive sides. Triangles have positive sides. Coordinates have negative values. Triangles have positive sides. Now r is the square root of x squared plus y squared. Since we're squaring these numbers, we'll never write a negative number in here. Positive 4 squared is 16, positive 3 squared is 9. R is the square root of 25, which is 5. Now you may have known that because you probably do know that 3, 4, 5 triangle is a right triangle, and it's well known that it's a right triangle. Okay, let's look at the definitions. Cosine, well, usually I start with sine, so we'll start with sine first. Sine theta, opposite over hypotenuse, 3/5. But by definition, it's the y-coordinate over the hypotenuse, or the r value, which is called the radius of the hypotenuse. So that's 3/5. That means cosecant is 5/3. Cosine theta. Now the cosine is defined as x over r. The x-coordinate here is negative. So that would be negative 4/5. And that makes the secant of theta negative 5/4. Now, one thing you're going to have, it's an easy thing to remember actually, is if the cosine is negative, the secant will be negative. The reciprocal function, secant, cosine, or cosecant with sine, they always have the same sign, S-I-G-N, as their reciprocal function. If this is negative, that's negative. Okay, tangent theta. Y over x. Okay, well, 3 over negative 4. Now that negative sign can be either here, out front, or on the top. A fraction is either positive or it's negative. If one of the numbers is negative, the whole thing's negative. Fractions can't be both positive and negative. It has to be one or the other. If any of the numbers in the fraction are negative, the whole thing is negative. Cotangent theta is negative 4/3. I can put that negative sign out front. All right, well, you're going to check these all by grapher. Okay, I'm going to slide this up so we can see the grapher. I keep them both in frame. Okay, we're going to find the reference angle in here, theta prime, by grapher. Now, this triangle has sides of 3, 4, and 5. I can find the reference angle by using cosine of theta prime, which is adjacent over hypotenuse, 4/5, sine of theta prime, which is opposite, or 3 over 5, or tangent of theta prime, which is 3/4. Any one of these is going to get us that value of theta prime. Watch. Now, I find theta prime by taking the inverse cosine of 4/5. Okay, inverse cosine 4/5. 36 degrees. Theta prime approximately 36.9 degrees. Now that is not theta. And how do I get theta? Well, what you have to do is you have to look at the situation that we have here. And this is 180 degrees, so if I subtract that little amount, or that reference angle amount from 180, I'll get theta. Okay, which I'm going to do. 180 minus the answer. Now you can get the answer back by going second answer here. Okay, that is theta. 143.1 degrees. I'm going to store that in theta because we're going to use it here to check our answers. Now, just to show you that I could have used any one of these three ratios to get that reference angle, watch. I'm not going to write it all down, but you can see this. I could take the inverse sine of 3/5, and I get that same reference angle. I can take the inverse tan of 3/4, and I will get that reference angle. Any one of those allows me to get this angle. Now you might say, why can't I just take the inverse, say, tangent of negative 3/4? Well, watch what happens. Inverse tan of negative 3/4. It doesn't give me the reference angle, it gives me this negative angle. which is very much related to the reference angle, but it's not the reference angle. Reference angles are positive acute angles. You want that positive angle. And the only way you get that reference angle is to use these positive ratios of the triangle. Never use the negative values of the coordinates to get the reference angle. Always use the positive values of the triangle. Positive ratios only. Okay, now what are we going to do with that reference angle? Well, we found theta, and you do it by subtracting from 180. Okay, well, we're going to just check then, see if we did this correctly. I'm going to check sine of theta. 0.6, that is 3/5. If you don't believe it, math, enter, enter. Cosine theta. That is negative 0.8, which is negative 4/5. Tan theta. Negative 0.75. Okay, so for these problems that you're going to do for your next assignment, there is no reason to get them wrong because you can check every answer by grapher. You have to plot points, and find these, write the reference angles down, or write the ratios down, find the reference angle, find theta, and then check by grapher. Okay, we will do one more. Okay, problem number 7. And you will do 3 homework problems, but I'm only going to do one more example. Okay, problem number 7 says find all 6 trigonometric functions or trigonometric ratios on a terminal side that passes through -2, -5. Okay, so the first thing we do is we draw -2, -5. Now I know that that's going to be in this third quadrant. You can draw the the crosshairs bigger than that if you want, but I'm just trying to make it a little bit bigger. -2, -5, something like that. Okay. There's the terminal side. There's the initial side. Here is angle theta. Okay, I'm going to draw this triangle. Okay, this side is 2. That side is 5. Now I find r by taking the square root of 2 squared plus 5 squared. Now that's going to be the square root of 29. That's not a perfect square this time, but that's okay. We can deal with that. Okay, so we got the square root of 29. All right, here's the reference angle that we're going to need in a little while. Okay, so I have all this information on my diagram, and this is a complete diagram. We got the coordinates, we got theta clearly marked, we got theta prime marked, we got the sides of the triangle all marked, we've got the value of r. Okay, now we're in position that we can write our ratios. Okay, the sine of theta. Remember, SOHCAHTOA, all students take calculus. I'll write that stuff down for us. And you can use by definition too, by those definitions that I wrote down on the other side. If you want to write those down and use those definitions, you can do that. I like this method myself. Okay, the sine is opposite over hypotenuse. But sine is not positive in this quadrant down here, only the tangent, so it's going to be negative. -5 divided by the square root of 29. Now we can rationalize that, but I'm not going to bother. That means that the cosecant, and we write that at the same time, is negative square root of 29 over 5. Again, since this fraction is negative, its reciprocal function is also going to be negative. Cosine of theta, adjacent over hypotenuse, 2 over the square root of 9, or 29 I should say. Cosine is not positive in this quadrant, so that's another negative. -2 over the square root of 29. Secant of theta is the reciprocal of that, negative square root of 29 over 2. All right, tan theta, opposite over hypotenuse, 5 over 2. Tangent is positive in the third quadrant, so that is 5 over 2. Cotangent theta is equal to 2 over 5, which is a reciprocal. If this is positive, that's also positive. Okay, we're going to find the reference angle. Okay, so theta prime. Now the easiest ratio to use here, I should say, is tangent, because both of these are integer values. We could use sine or cosine, but we'd end up using that square root of 29, which we really don't want to do. Okay, so I'm going to write tan of theta prime is equal to 5 over 2. Theta prime is equal to the inverse tan of 5 over 2, so theta prime is approximately, let's put this in here, inverse tan of 5 divided by 2, approximately 68 degrees. 68.2 we'll call it. Okay. All right, I'm still in frame, I can see that. Okay, so we'll find theta. Now, how do you find theta? Well, we got to look at the situation. This last time we subtracted from 180. This time we're going to add to 180. So I'm going to take 180. Since this number is right on the screen, I can do this, plus 180, and it tells me my theta, approximately 248.2 degrees. All right, we're going to store that in theta, and then we're going to check these values. Okay, first thing I'm going to do is check sine of theta. Okay. First thing is it's negative. Well, that's good. We got a negative here, we got a negative there. Now, this number is probably not on the tip of your tongue, but what we have to do is check whether this value, 5 divided by the square root of 29, is that decimal amount. Now, I'm not going to type the negative in here because I don't even have to. 5 divided by the square root of 29. Okay, since this decimal value matches exactly 5 divided by the square root of 29, I know I'm right. I got a negative when I checked the theta, and I got this decimal value. Let's do the cosine. Cosine of theta. Okay, again, negative comes back, which is good, because we were expecting a negative, we had a negative there. Okay, now we're going to divide 2 by the square root of 29. And we get that decimal value that exactly matches. That means we got that one right too. These ones, the reciprocals, you don't have to worry too much about that. If you can write a fraction, you can flip it upside down, keeping in mind that since this one's negative, that one's negative. Okay, they always follow. All right, well, let's try tangent of theta. It's positive, and it is 2.5. Well, okay then. That's what you will do for your homework. Okay. Well, actually, for your assignment. Okay, for the assignment, you've got section 5.3, numbers 2, 4, and 8. Okay, number 4 is a first quadrant. We didn't do a first quadrant example, but we'll, the first quadrant, everything's positive in the first quadrant. And the reference angle is the same as the angle itself. So when you find that angle, it will be the reference angle. So I should have mentioned that. In quadrant 1, number 4, I'll make a little note of that down here. Number 1, quadrant 4 is a quadrant 1 angle. It's the point 3.7. Okay, got a 3 and a 7. You find the R. But this is theta, and it's also theta prime. It's both. You can't really see that, I guess. That's theta and theta prime. Okay, until tomorrow.